Sustainability science, folklore and culture studies? If yes, the School of Interdisciplinary and Transdisciplinary Studies offers various programs like Master's Program, Graduate Program, Postgraduate Diploma, Certificate and Appreciation Program. The school offers 5 Master's Programs. Master of Science, Environmental Science. The eligibility criteria for MSc Environmental Science is Graduate in Science, BTech, BE, Agriculture Graduate, Forestry Graduate and Veterinary Graduate. School also offers Masters in Environment and Occupational Health, Masters in Sustainability Science, Masters in Philosophy and Masters in Folklore and Culture Studies. The eligibility criteria for these 4 Master's programs is graduate in any discipline. School also offers various socially relevant and need-based PG Diploma programs like PG Diploma in Sustainability Science, PG Diploma in Environment and Occupational Health, PG Diploma in Folklore and Culture Studies and PG Diploma in Migration and Diaspora Studies. The school also offers PG Certificate in Climate Change and Avshist Prabandhan Mein Praman Patra. The school also offers 2 doctoral programs, PhD in Environmental Science and PhD in Interdisciplinary and Transdisciplinary Studies. The school offers various innovative technologies and multimedia for providing a very excellent student support system. The study material is of high quality. The learner support is provided through Gyan Darshan, Gyan Vani, IRC, Swayam Prabha and Swayam channel of IGNOU. For more detail, please log in to IGNOU website. For online admission in these programs, visit school site and also the Samarth online education portal of IGNOU. So please join these programs and fulfill your educational aspirations.
Hello and welcome to the session. In today's session, we'll be discussing about concurrent transaction and the associated anomalies or the problems associated with these concurrent transactions. Take a very simple situation. Let's take a banking environment. And in a banking situation, what goes on? Number of people are doing transactions about data. Somebody is withdrawing the money, somebody is transferring the money to another account, somebody is just depositing the money into his or her account. So all these simultaneous transactions are going on. These are all online transactions. And where exactly the data is getting stored? In the database system. So the database system allows these multiple transactions at a simultaneously as they are going on. But consider that you are performing 2 transactions or let's say 3 transactions. One is that you are depositing the money through a check, let's say. On the other hand, you are withdrawing through the ATM and you have issued another check to somebody and he has submitted that particular check. Now the problem in this particular case is that all these 3 transactions are related to your account. So can there be any problem associated with this particular situation? Well, this is what we are going to discuss today. So let's look into the slide, which basically identifies, so we know DBMSs support multiple simultaneous transactions which should not affect each other. That is our objective. But concurrency related problems may occur in database if two transactions are contending for the same data item, that is your account in this particular case, and at least one of the concurrent transaction wishes to update a data value in the database. So suppose you are withdrawing the money, obviously the balance will be read and then it will be updated, right? So the withdrawal will take place and the account will be updated once again. You are depositing the money, update is going to take place, right? Your account balance is going to be updated. So this particular updation is there, written back. So everything seems to be perfect, right? There is absolutely no problem in this particular case, okay? Absolutely no problem. As far as two transactions are going on, there is no situation. But there can be another situation over here. Okay, once again, now in this particular situation, the complete transaction T1 is being read initially, okay, or read, subtraction, then return, then read, once again added the amount in Y and written the value of Y. And what we see, the output is still that Y gets 1,100,000 and X reduces to 49,900. Now these two values are added, right? At this point of time, these two values are added, Y and X. The changed value of Y and X are added, and still you get your 1,50,000 as your balance. So in both the cases, if you see the updated amount, right? Updated amount is 1,50,000. So this was the sum of X and Y, right? And during the process, amount of rupees 100 was transferred from amount X or from account X to account Y. So that happened successfully. There was no problem, and after the end of the transaction, even the balance was 49,900 and 1,100,000. So that was perfectly all right. Everything seemed to be all right. But can there be a problem? Well, let's look into the third situation. Now, this is called an interleaved transaction schedule, right? So, interleaved transaction schedule can happen because these transactions are going on simultaneously, right? So, whichever transaction is executed, so suppose these three statements of transaction T1 are executed first, then they are followed by transaction T2, and once again the remaining statement of transaction T1 are executed, right? So what happens in this particular case? Now look into the result. X was 50,000, reduces that because subtract operation has happened, so it reduces to 49,900. X is written back and it now contains 49,900. So that seems all right. But what happens during this particular transaction? This particular transaction has not yet completed, but another transaction now has taken over, right? So the transaction T2 gets executed at this point of time. So it reads the value of X, which happens to be at this point of time, it was written as 49,900. So it is going to read 49,900 at this point of time. Then it reads Y. Y at this point of time is still 1 lakh, right? So what happens that on reading the value of Y, you get just 1 lakh of rupees in this particular case. And when you display X plus Y, you get 1,49,900 as your sum total. Now this transaction get completed. The remaining portion of transaction T1 starts executing once again. So what we get at this point of time, you read Y, you add that 100 value which you have subtracted earlier, and then the value of Y has been updated. Now the value of X and Y happens to be all right, right? X after this particular transaction statement, X is 49,900, Y is 1,100,000. That's perfectly all right. But what you see, the displayed value is 1,49,900 only. So there is a loss of 100 rupees in this particular information. So what you can say, so this is definitely a problem, right? So this is the first problem which, you can see that when two transactions, when they interleave with each other and interleave in such a fashion that their statements overlap, then there is a possibility of such a situation. Please remember one particular thing. All these transaction schedules are normally designed with read before write protocol. Like if you want to write some value, then first read it, then if you update it, and then you can write it. So that reading is first. So you read value, then you update it, and then you write it. So if that particular protocol is followed, then only these kinds of things are going to be valid in that particular sense, whatever we are talking about. But in general, this is what is the normal protocol. Now let's look into what can be the possibilities of errors in these kinds of situations. We call them anomalies, which can occur when you are dealing with concurrent transaction. So there are three basic problems which can occur. Okay, so anomalies due to concurrent transaction. The first one is called lost update anomaly. All right. The second one is called unrepeatable read anomaly. And the third one is called dirty read anomaly. Now these are very, very specific type of problems which you should know in order to handle transactions. So let's try to understand lost update anomaly or lost update problem in that particular sense. So suppose we have two transactions. Okay, one transaction you have withdrawn some money, and in another transaction you have deposited the money, and assume that they are going on simultaneously. Then what can happen? So let's look into the slide. Okay, so suppose transaction T3 and transaction T4, right? So these two transactions are going on simultaneously. So it reads the value of X. Okay, so transaction T3 basically withdraws rupees 5,000, and in transaction T4 is that it is depositing rupees 3,000. And assuming that these transactions are executed in this particular way. So transaction T3 reads the value of X, that may be your account number, which rated it to 4,000. So the original value was 2,000. T5 updated that value to 3,000, and T6, after reading the value of T5, updated it to 4,000. No problem so far, right? There is absolutely no problem because updates have been run separately. Complete updates are separate. But an unfortunate situation occurred. There is a rollback. That means T5 transaction is rolled back. Rolled back means it is somehow truncated, or it is finished, it is completed. So the value of X, right, when rollback takes place, so the value of X will be reset to value 2,000. Whereas this particular transaction has already read this 3,000, right? So rollback is going to bring the value of X to 2,000, and it has already read 3,000. So it has updated the value of X to 4,000, and that 4,000 value now has been changed to 2,000 at this point of time when the rollback has taken place. So whatever update has been made by T6 now has been lost because the value has been updated to 2,000, or it is now the original value, which happens to be 2,000. Now this is another kind of lost update anomaly. So once again you have lost an update, right? In the previous case, the lost update turned out to be beneficial because your balance got slightly higher. But it could have been other way around also, right? And in this particular case, you have lost it. But in both the cases, a different kind of interleaving, you may lose the information, lose the data, right? So what you see basically is there is an update, a loss of a particular updated information. And this is not permitted. This is going to lead to inconsistent results. And obviously, inconsistent results are not allowed. So obviously, you will be writing better programs. Let's look into second problem. It is unrepeatable repeat anomaly. Now what happens? Assume that T7 and T8, right? So these two transactions are going on. Okay. So T7 reads the value of X and assume that it is 2000. Meanwhile, it goes on like T7 gives control to T8 and T8 reads the value of X once again, which is 2000, and then modifies it to 3000 and updates the value of X to 3000. So this has changed the value of X to 3000. So obviously this is going to create problem or the further problem when you are looking into this particular situation. So these are the three different kinds of problems, okay, main anomalies which you can encounter when you are dealing with transactions. Now what you should be doing? Obviously you will be making sure that when this kinds of updates are going on, the other transaction is not able to see those updates, right? Then it is going to be possible that you will be able to save one transaction from another transaction, and that is where the locking protocol, right? And even in locking protocol, typically the two-phase locking protocol, which may be discussed in subsequent sessions, but that is what is required, or that is what is going to be useful. So let us try to summarize what we have discussed in today's problem. In today's session, we have restricted ourselves to defining the problems related to concurrent execution of transactions. Remember one thing, that if two transactions are contending for data resources which are not related, no such problem is going to occur. However, if they are contending for the same data resources, right, or data resources or data values, then there may be a problem, right? And that problem can be solved with the help of doing proper programming of each transaction using the proper two-phase locking protocol or other techniques. There are many other techniques which you can utilize to address this kind of a situation, right? So the three problems, remember the three problems: the lost update problem, the unrepeatable read anomaly, and the third one is dirty read anomaly. And always remember what the term schedule. Schedule is a very important term when it comes to transaction management or transaction handling of transaction. You always make schedule. And if the schedule are conflicting, they are resulting into these kinds of problem, then we go on to do certain additional things. So with this, we end this particular session. Bye for now.